Hi viewers, I take the pleasure of inviting you to this session. In this session, I am going to discuss with you an important reaction of alkanes. We know pretty well alkanes are highly inert compounds because they contain only sigma bonds which are very strong in nature. Yet, these alkanes, when they undergo halogenation, they show high amount of reactivity as well as selectivity. So, let us look at the principle of reactivity versus selectivity by comparing the chlorination and bromination of alkanes today. When we observe the chlorination and bromination of propane, surprising results were observed experimentally. What happened? In propane, there are 8 hydrogen atoms. Out of these 8 hydrogen atoms, 6 hydrogen atoms are connected to the terminal carbons, namely 1 and 3. Whereas 2 hydrogen atoms are connected to the middle carbon. So these are called as secondary hydrogens. So totally there are 6 primary hydrogens and 2 secondary hydrogens. If all these hydrogen atoms are having same reactivity, then according to probability, we expect the product formation in the ratio 3:1. That is, primary product should be formed to the tune of 75%. And secondary product should be formed to the tune of only 25%. But experimental results are observed to be very different. Experimentally, we observed 55% of secondary product, namely 2-chloropropane, and only 45% of 1-chloropropane primary product. This proves that all the hydrogen atoms present in propane are not having same reactivity. Secondary hydrogens are more reactive compared to primary hydrogen atoms. Why the reactivity of primary hydrogen and secondary hydrogen in propane are different? We know pretty well that the primary hydrogen and secondary hydrogen in propane are present in different environments. As a result, their properties are different. Not only that, if we consider the experimental bond dissociation energies of CH bond, when it is connected to primary carbon and secondary carbon, they are different. In what way they are different? The primary carbon hydrogen experimental bond dissociation energy is 98 kilocalories per mole, whereas secondary carbon hydrogen bond dissociation energy is 95 kilocalories per mole. As a result, this 3 kilocalorie per mole energy difference makes all the magic that we are observing. And we are getting more secondary product compared to primary product. If we continue to proceed with bromination of propane, we expect similar results to that of chlorination of propane, which means we expect 55% 2-bromopropane formation and 45% 1-bromopropane formation. But here, surprisingly, we are getting 97% of 2-bromopropane formed, only 3% of 1-bromopropane formed. Why is this vast difference between the chlorination and bromination of propane? Let us explore this. Why chlorine atom has less selectivity compared to bromine atom in case of halogenation of alkanes? If we observe carefully, during chlorination of alkanes, we are going to get HCl as byproduct, whereas in the bromination of alkanes, we get HBr as a byproduct. If we closely observe the bond formation energies of HCl as well as HBr, there is a difference. This difference makes the reactions via a different transition states. Chlorination, we have early transition state formation, whereas bromination is a late transition formation reaction. Chlorination of alkanes is an exothermic phenomena, whereas the bromination of alkanes is an endothermic phenomena.